All right, good evening, good day, everyone. Here's another video discussing samples of problems involving arithmetic sequence and series. So let's proceed. As for this one, we're only going to focus on one formula, although there might be questions that will be using the nth term or maybe the sequence or the one for series. It depends on the situation. So consider the illustration here. This was actually one of the explore activity named "What's the Trend?" but we weren't able to tackle this one. So due to some we call this um time due to time constraints, no. So hopefully this will be much easier now since we've already discussed naman the concept first before you tackle this one. So suppose there are 500 seats in the innermost row. Each successive row contains 100 more seats from the previous row. There are 25 rows. How many seats are there in the last row? How many seats are there in all? So we have here first question, the total number of seats in the last row. So when you say a specific row, then we're going to use the arithmetic sequence, the n term of a general formula for the n term of a geometric arithmetic sequence. Meanwhile, when you say how many seats are there in all from the first row to the 25th row, then that talks about the totals or sum of the number of seats from first row to the 25th row. Then that involves arithmetic series. So the first question says, for the first term, it now has for the first question, how many seats are there in all in the 25th row? You have already there the answer. Okay, I'll just point to you the given. First term is 500 for first row, and then where did you get the common difference 100, sir? So in the problem it says here the each successive row contains 100 more seats. No, 100 more seats. This is the the idea that we're only adding, addition of number of seats compared to the previous row. So that's your common difference. And it's asking for how many seats in the 25th row, so therefore your n is 25. We're going to look for the A25. So we're going to use the formula an equal to a1 plus n minus 1 times t. A25, replace n with 25, and then first term is 500 plus n, which is 25 minus 1 times common difference 100. So 25 minus 1 is 24 times 100 will be 24,000, 2,400 plus 500 in the first row is 2,900. Therefore, there are 2,900 seats in the 25th row. Questions? If you have questions, feel free to ask that one in the comment section. On the second question, how many seats are there in all from the first row to the 25th row? You have here the first term is 500 still, and then an, because an here, an or the last term, because that's the 25th term, this is supposed to be a25 is 2,900. Suppose you don't know the a25, use the longer formula. Since we already know the formula, the last term, which is 2,900, we can use the shorter one. Remember, in arithmetic series, we have the shorter one, which we have the first and last term, and likewise the end. If we don't know this part here, we have to use first the longer formula. Okay, you have two options. So we replace n, which is 25 over 2 times 500 plus first term plus the last term 2,900. Sum of the two is 3,400 times the quotient of 25 over 2, which is 12.5. You'll get 42,500 all in all from first row to the 25th row. Therefore, there are 42,500 seats in the stadium. Another problem, a stack of telephone poles has 30 poles in the bottom row. There are 29 poles in the second row, 28 in the next row, and so on. Now, how many poles are there in the 26th row? Remember that when you stack items, you're going to stack from the bottom as well. So basically, the bottom is your first term. Now, also when you stack items or let's say blocks, in most of the time you have to decrease the weight. Likewise, the number of poles will be decreasing as well. So that's why in the bottom row you have here the 30 poles, 29, 28. It decreases by which decreases by one. So your um first row you have 30 poles, and then in the end, the question is how many poles are there in the 26th row. So question is how many poles are there in the 26th row, and then n will be 26, and then the common difference is -1. You cannot say +1 because it's decreasing from the bottom to the top. And question asked is A26. What is the unknown? The unknown quantity is the A26. Simply use the AN. AN equals A1 plus N minus 1 times D. A26 since N is equal to 26. And A1 is 30 plus 26, which is N minus 1, times the common difference, -1. 26 minus 1 is positive 25, but you have a -1 outside, so it's now -25. You're supposed to put this into, or place that into those open parentheses. Now, 30 plus the -25 is basically 30 minus 25. 30 minus 25. And that's why on the 26th row is equal to 5, which makes sense because as the sequence, or as the pile goes up, the number of poles will decrease as well. Therefore, there are 5 poles in the 26th row. We'll go down to the last example. Think about a machine worth not 29,000. It depreciates in value by 500 each year. In which year of service would the price be 24,500? The word depreciate usually is associated with decreasing value, synonymous to decreases. But it can also be used on other sequence like geometric sequence. It's possible, but in this case, the depreciating value is exactly 500. So you cannot use the geometric sequence here, or you cannot apply the geometric sequence unless this is in percentage. But since it's a fixed value, you can associate that with the common difference. So in which year of service would the price be 24,500? So here we have the first term, 29,000, 29,000. And the common difference is 500. This one is a particular price for a specific year. So we have to look for that N, which is the number of years, or the position N. So A1 is 29,000. AN is, which is basically the term we're looking for. And then D is equal to -500. And therefore is the missing part. Okay, which year of service is 24,500. Let's start with, still going to use the same formula. AN is the year. I mean the amount of that year we're looking for, which is the N. 24,000 equal 24,500 equal to first term, which is 29 plus N minus 1 times -500. The reason why we have N like this is because we are looking for N. Simply do the APE or SPE, subtract 29,000 on both sides. you'll end up 24,500 minus 29,000 equal to n minus 1 times negative 500. You do distribute the or multiply negative 500 on all the terms inside the other parentheses. So you'll have negative 4,500 equal to negative 500 n plus 500. Now, we're going to apply the SPE again, minus 500 on this side, minus 500 on this side as well. So you end up with negative 5,000 equal to negative 500 n. And dividing both sides by negative 500, which is the coefficient of n, you'll end up with n equal to 10. Therefore, the price in the 10th year will be 24,500. And that will be all for this video. If you have questions, feel free to message me or comment in the chat box or the comment box.